Welcome to the Bob Bloom Show with your host, Bob Bloom, a production of South LaSalle. Welcome to episode 32 of the Bob Bloom Show. Go modules, the net HTTP package, Go Compilation. Today is Saturday, November 1st, 2025. The Bob Bloom Show is a monthly commentary PHP passion podcast devoted to PHP serverless, published on the first of the month. This is your podcast host, Bob Bloom from Toronto. I organize the Greater Toronto PHP and Laravel Toronto groups. Head to gtaphp.org for info on our groups. It is with deep gratitude that I express my thanks to my intrepid sponsors of my PHP serverless project, of which this podcast is a part of, Toga Aircat and Luca Leah. I also want to thank my family for their amazing ongoing support of my PHP serverless project. Links referenced in this episode are listed in my notes at bobbloomshow.com, episode 32, and you can listen to this podcast on my website, RSS, Spotify, Apple, and YouTube. This is my third of three sequential episodes about my personal journey into the FrankenPHP application server. In my first episode, I go over my inability to make heads or tails of FrankenPHP, along with a similar experience with the server it is based on, the Caddy server, and ultimately with the Go programming language that both servers are written in. This is my third attempt trying to make heads and tails, trying to make sense of it all, and an attempt that started very badly. The stumbling blocks that thwarted my second attempt were the starting point of this renewed attempt to understand FrankenPHP, Caddy, and the essential features of Go that both servers rely on. These stumbling blocks were my lack of low-level technical knowledge, my intensely shitty attitude, my the prolific and confusing use of technology and lexicon, and plus, my learning process stopped working. In the first episode of this mini-series, I describe the two things that powered my personal breakthrough to understand it. I actually gave up on this third attempt, but then I persevered anyways because the PHP Foundation now officially supports FrankenPHP. And if this thing is important to the PHP Foundation, I really should figure it out. The second thing was probably more profound, was I changed my learning process. I threw away traditional searches. I threw away trying to piece together answers, and I switched to ChatGPT. And this process, the process of asking questions, getting answers, and following those answers with more questions was amazing. My hunch that I should understand what a Linux process is and what a Linux thread is proved prophetic. I answer these questions in my August episode titled Threading the Process. I enumerated 4 features of Go that I think are essential to FrankenPHP. Go routines, the first-party net HTTP package, Go modules, and Go compilation. I talk about Go routines in my previous episode, and I talk about the latter 3 in this episode. I will start with Go modules. It's not really much to say. This is Go's package and dependency management mechanism. PHP has a composer, Go has its modules. And that's it about Go modules. On to Go's first-party net HTTP package. When Google created the Go language almost 20 years ago, Go needed to communicate on Google's internal networks. Consequently, Go has first-party support for common communication protocols. Google built these as foundational packages, providing network protocols that could be included or omitted as needed. ChatGPT says that Go included these protocols when Go was originally released as open source in 2009. TCP, UDP, IP-level networking, DNS, HTTP, HTTP-based RPC. The net HTTP package provides HTTP client and server implementations. The Caddy server started out as features built on top of Go's net HTTP package. Compiling. Compiling in general. Go's compiling. How is it that I got it to my head that compiling is important? How is this an actual thing in FrankenPHP? PHP. Well, I got it into my head because on FrankenPHP's website, on its homepage, has this statement: build standalone self-executable and dependencies-free binaries for your PHP web applications and command line tools. I thought maybe this had to do with FAR. FAR.net describes FAR as a convenient way to group several files into a single file. As such, a FAR archive provides a way to distribute a complete PHP application in a single file and run it from that file without the need to extract it to disk. And I also subsequently learned of an interesting project called PHPacker, 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 which enables you to package any PHP script or FAR into a standalone cross-platform executable. It handles all the complexity of bundling PHP with your application, making distribution simple and hassle-free. I also know that native PHP has a docs page devoted to building binaries. And you know what? I'm not going to quote from it. I got a 3-line quote. Perhaps compilation, I think it's sort of a little mini trend that's come around. I also think that compilation is a way maybe to use serverless platforms that do not support PHP. Maybe compilation is a way to just deploy to a server easily without setting up PHP. So I don't really know about compilation. All I know about compilation is that it turns code into a file that can be executed on its own. But what is compiling about? Compilation is translating your source into machine language. Well, what is machine language? Well, the CPU runs a program, and the only thing the CPU understands is machine language. Machine language contains the instructions that a program needs the CPU to carry out. An instruction is a single low-level command that tells the CPU exactly what operation to perform. An instruction set is the complete collection of all instructions that a particular CPU model can execute. The instruction set for ARM, for example, is different than the instruction set for the Intel's x86 CPUs. Machine language is readable by the CPU, not so readable for humans. Assembly language is a human-readable form of machine instructions, well, somewhat human-readable. Go is a compiled language, and Go is designed to compile quickly. Google was contemplating creating a new language because in part of their intense frustration with C's slow compilation. Now, Go will not compile when there are unused variables. Go will not compile when there are unused imports. Go will not compile when there are mismatched variable types. Go prioritizes fast compilation over aggressive optimization. Go supports cross-compilation across diverse platforms. Go allows for external dependencies during compilation. Go handles external compilation during compilation using the Go module system. Go modules are the standard way to manage external packages. All external code is compiled into the final binary. There's no separate linking to external dependencies at runtime, and there's no dynamic linking to external dependencies at runtime. You can use code that is stored outside of your compiled binary. Your compiled binary can keep track of where external code resides so that it can find it when it needs it. This is called dynamic linking, but Go does not do dynamic linking. This is something that I had to kind of drill into my head. Go does static linking. All Go dependencies are statically linked into the final binary. This means that the entire application, including all external packages, compiled together. This means that all the source code is subject to the same compiler, type system, memory safety rules, and tooling. Statically linked means that all your dependencies are compiled and bundled directly into the final executable at build time. When you run the binary, your binary does not need the external shared libraries. Alternatively, your binary does not need to be dynamically linked to external shared libraries at runtime. Everything that is needed is already part of the binary, so you end up with one self-contained binary. Go imports external source code. Imported source code is then treated like you wrote it. Once imported, there's no distinction between code you wrote and code that came from someplace else. There are no internal boundaries after compilation. After compilation, Go does not keep third-party code in a separate section of the binary. Everything is flattened into one code base. Go resolves all function names, variable references, and types when compiling, not at runtime. Once linked, the final binary contains direct machine code calls to function addresses with no need to find or load anything at runtime. Static type means that the variable's type is checked at compile time, and dynamic, you know what? Forget about dynamic. There is a package that Go has called CGO. CGO is a Go feature that lets Go programs call C code directly and lets C code call back into Go. Why would Go allow for use of C? Google had a lot of C code when Go was originally released in 2007, and they wanted to use their C code. They did not want to be pressured to rewrite everything in Go right away. And they wanted access to proven C libraries. Another reason is for those times when a Go developer needs lower level control than what Go allows. I was thinking, CGO is how FrankenPHP compiles PHP feature code into a Go binary. I asked ChatGPT about that, and the answer is no. FrankenPHP compiles with Go and uses Go's first-party package called embed. Embed allows you to embed files and folders directly into a Go binary at compile time. FrankenPHP uses the embed package to bundle PHP scripts, config files, and web assets into the final executable. These embedded files are not compiled in the sense that they are converted to machine language. Instead, they exist as raw data. The contents of the files and folders are included in the final binary, essentially as is, unchanged. And this is something that's just sort of the appetizer. I really don't quite understand it, and I'm going to have to dig into this later. The final compile Go binary file contains a bunch of things. It contains your app's source code translated into machine language. It contains the Go runtime compiled into machine language and statically linked into the binary. The Go runtime provides low-level services necessary to run Go programs such as Go routine scheduling, memory management, and garbage collection. The final compiled Go binary file contains the standard Go libraries, which are imported, compiled into machine language, and then statically linked. It contains any data that is embedded using the first-party embed package. This stuff's not compiled, nor parsed, nor transformed. It is basically included verbatim. Thank you for listening to this 30-second episode of my Bob Bloom Show. Go modules, the net HTTP package, Go compilation. My next episode is scheduled for December 1st. You have been listening to a South LaSalle production. Opinions expressed are not necessarily those of South LaSalle, Bob Bloom, nor of the organizations represented. Links and materials discussed on air are available in the show notes for this show. Information contained herein have been obtained from sources believed to be reliable, but are not guaranteed. Podcasts are released under copyright. Rights are reserved. Email correspondence to the attention of Bob Bloom at bob.bloom@lasallesoftware.ca.